Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 26, 2025, about 3 days ago. This paper introduces MAI-UI, a family of foundation GUI agents, and it hits a new state-of-the-art 76.7% success rate on Android World, while also reaching 73.5% on ScreenSpot Pro. The paper is titled MAI-UI Technical Report, Real-World-Centric Foundation GUI Agents. Okay. And as we go on, the device cloud collaboration and online reinforcement learning pieces get really interesting for real deployment. Figure 1 makes the main claim concrete, which is that MAI-UI leads on both GUI grounding and mobile navigation. This figure shows the full benchmark summary, so it acts like a scoreboard for accuracy and success rate. The left panel focuses on GUI grounding, where performance rises with model size, and MAI-UI sits at the top. The middle and right panels compare navigation success rates, and the best MAI-UI variant takes the top spot on Android World and Mobile World. Figure 2 explains what it looks like when the agent actually solves a real phone task, not just a benchmark. The full figure lays out a route planning request, where the agent first asks the user for missing details, which is agent-user interaction for clarification. The left side summarizes the action space, mixing standard taps and typing with MCP tool calls that jump straight to an application programming interface. The bottom left also sketches device cloud collaboration, so a local agent monitors and only escalates when needed. Table 1 nails down what the agent can actually do on a phone, which matters because capability starts with the action space. This table shows the full set of actions, mixing basic touch controls like click, long press, swipe, and drag with system-level buttons and wait. It also adds terminate and answer, so the agent can stop correctly and reply in question answering. The key extensions are ask user for clarification and MCP call, which means calling an external tool with arguments instead of tapping through the interface. Figure 7 shows how device cloud collaboration makes a phone feel responsive while still getting help from a bigger model when needed. The full diagram lays out a local agent that both acts and monitors, and it only escalates when it detects task deviation, and the screen is not privacy sensitive. The center unified trajectory memory is a shared scratchpad, so both sides stay consistent using user instruction, screenshots, and an error summary for recovery. Table 6 shows that these agents translate into higher real task success on Android World, which is a live emulator benchmark scored by completion rate. The full table compares many baselines against the MAI-UI family across model sizes. In the hours block at the bottom, the best result is MAI-UI 235 BA22B at 76.7%. The same block also shows 73.3% for MAI-UI 32B, so it stays strong even without the largest model. Table 9 shows that online reinforcement learning reliably boosts Android World task success, so the agent gets better at finishing real phone workflows. This table lays out the full comparison between supervised fine-tuning and reinforcement learning across model sizes, and each scale improves. The lower block tests GRPO, which is a policy optimization recipe for reinforcement learning, and the gains stay modest there. The interaction budget, meaning how many environment steps the agent is allowed per attempt, drives larger improvements when it increases. Alright, 2 takeaways stand out. MAI-UI gets strong real phone performance by expanding the agent action space, including ask user and model context protocol tool calls, and it stays deployable through device cloud collaboration that cuts cloud calls while protecting privacy. The broader implication is that robust GUI agents need systems engineering plus learning at scale, not just bigger models. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.